title of my talk tonight is SQL on Android Rise and Shine. I want to go over some implementations of SQL for Android. If you have an app of any complexity at all, and you have a lot of data that is queried dynamically, you probably have some kind of database. Android and iOS ship with SQLDelight built in, but there's a lot of different ways to use it. So what I want to do is to look at 4 different implementations. First one I'm going to call the vanilla API. This is the one that comes with Android. One, a typical ORM, if you've used object relational mapping before, called ORMLite. And the last 2 are more recent entrants in the field. One called SQLDelight and one called Brew. I want to go over the existing stuff because it gives us some context about why some things are done a certain way and where some of the legacy compatibility stuff that we have comes from. And then see how it's influenced the development of these newer libraries. So things I want, hopefully, that you'll take away from this talk are just getting an appreciation of what's out there. Perhaps give you ideas for what you might want to explore if you're starting a new project, and evaluate that for your own needs. Okay, so let's start with this vanilla API. So this is a small package that has shipped with Android since day one, since API 1. And I'm just going to refer to this as the vanilla API because it's quite plain. It's a very thin, lightweight wrapper around the embedded SQLDelight engine that ships with Android. And your main touch point with the library is the SQLDelight database class. So to start, why don't we have a look at how Android's documentation says that you should use it, which is, I think, a good place to start. How much of the work that you have to do on your own, how much they do for you. Okay. Oops. First thing we need to do is define our database schema in a contract. So the way to do that is to have, or to organize all your different tables where you're going to hold the data in inner classes. In this case, I have one table definition called feed entry inside the contract class. And I define string constants for all the table names, or the name of this one table, and all the columns within. Pretty straightforward. Key thing to note is that these are just public string constants. The next thing you need to do is interface with this helper. Now, you might wonder why this helper exists at all. It's a little abstraction that Android helpfully provides so that you know when you actually need to create a database. So obviously, on the very first launch of your app, there is no database, so you need to create it. But on subsequent launches, you can just connect to the existing one. So the SQLDelight open helper automatically calls the onCreate method when your application actually needs to create a database. So if you know SQL, if you know the relational theory, this is where your data definition language statements would live. So this is the SQL statements you would need to create to actually make the tables. Or in the second string there, you might want to delete them. So you notice I've defined them using good dry principle, referencing the string constants that we had in our contract. And we have the constraints, the types that we want on those columns. And then we hook them up by passing them to this callback. So all we're doing is we're taking those string constants and calling a method on the database class called exec_SQL. Okay. Next, how would we get data into the database? Well, what Android's vanilla API uses is an abstraction called content values. This is just a key value store. It is nothing more than just a map where all the entries keys are strings. So if you notice, we're using the column names for the keys, and then in my example, your title and subtitle are from somewhere in your model. Once we have this content values object built up, we can call a method on the database called insert, passing in the string constant for the table name, and then the content values as the last argument. Now, content values is a mutable type, so you can put something in and then change it or remove it. If you look carefully at the package that content values comes from, it's actually not from Android database like the rest of the SQLDelight classes. That's because Android has an abstraction called content providers, which has anybody used content providers or suffered through content providers? A few of you. Try to stay away. Content providers are sort of a general mechanism for apps to provide content, of which a persistent thing like a database is one thing, but it could be from other places. But the content value is borrowed from that package for use in the SQL API. Okay, so now suppose we have some data in our database, we've created tables, and we want to get the data back out. So the first thing to do is to define our projection. So projection is just a fancy way to say which columns you want. You don't always do a select star. You don't always want to retrieve all the columns of your data. You sometimes just want a subset of them. We have a very toy, simple example here. So the projection is actually all the columns, but you get the idea. We're referencing those string constants for the column names that we find in our contract. And the next step is to define our filter. So a filter, you might better know this as the where clause from your SQL statement. You build it up, again, with a string, referencing those column names. You see those question marks, those are placeholders where you're going to bind your actual arguments for the query. So in this case, I am trying to query our feed entry table, selecting both a specific argument for both the title and the subtitle. And the way that you do it is you define sort of that placeholder, the string with the placeholders for the arguments. So in the comment there, I have what the substituted string selection is. And then you have an array of string arguments, which is the values you're going to substitute there. So if you're building some sort of form interface, the user might type in the title of the article they're looking for. You would put that as the first argument in selection args. Now they're positional. So the first argument in selection args matches up with the first question mark in the selection. How many of you are a little bit disgusted right now that we're doing so much string manipulation? It's not going away, I can tell you that. All of these strings pass into the 7-argument method called query. So you pass in the string representing the table name, you pass in the projection of the columns you want, you pass in your selection and down arguments. You might want to have other things like grouping or sorting. Once you do all that, you get back, as you can see from this call, you get back a cursor object. Cursor is just an abstraction over your database results. A cursor is an object that is iterable, so you can go forward through all your results, and it's lazily loaded. So it doesn't actually pull your results until you actually ask for them. So with a cursor, we have an abstraction of what the database results are, but we're working in Java here, and we want to get our model objects out. So we have to map from the cursor values back into our model object. So I'm going to call our feed entry the feed entry model. It's going to have 2 string fields in it for the title and subtitle, and then I think an int or long for the ID. So we create an instance of an empty model object. We're going to take the results from our cursor. So the cursor you see in the top of that while loop there, we're just walking through, we're iterating through all the results. And then the current cursor position, when you call one of the get methods, it returns you the column at that particular row. Now you see the argument to get long is actually an integer, which is the number of the column. So the database has a strict ordering of what the columns are, and you need to map that up. So if you change the order of your columns, you're going to have to change these IDs. So to have sort of one level of abstraction above that, you can actually look at the column index from the string name of that column, which is what the inner statement there, get column index or throw is. All right, so now once we get the value out, we're doing the mapping ourselves. We know what the type of those columns are. And how we know that? We just know that's encoded in this boilerplate code. And we assign that back into our model object. Once you have that, you can add that new model object into your collection and then return the whole thing. So now you've done some SQL before maybe, and you're thinking, oh, well, that's like the most basic select query I can do, but what if I do joins? What if I do group bys and aggregate functions, all that? That's no problem. The vanilla API gives you full access to all of SQL. But full access means just writing the string yourself. So you can write any SQL you want, valid syntactic SQL. We're going to be good, again, about not repeating ourselves, and we have all the string constants for our table names. And then once we have our SQL built, we call it a method on the database called raw query. Now, remember we said that it's not going to get any prettier with the string concatenation? Well, this is not even that complicated either, right? I don't actually even have any grouping or aggregate functions, any complicated subselects, anything like that. So at this point you're thinking, really? This is the API that Google in their infinite wisdom has given us to use. I find it kind of funny that even Google in their documentation says, although these APIs are powerful, they're fairly low level and require a great deal of time and effort to use. Okay, so to summarize, the vanilla API, well, what it has going for it is that you don't have any dependencies, right? It's just built into Android. No bulking up of your API. You have full access to SQL. They just don't help you much with that. However, you do lots of boilerplate. So I just showed one simple query where we had to map from the SQL columns back. We had to call getLog, getString back into our model objects and assign them to the fields. We had to do all that ourselves. And then going the other way too. So if you have your model objects, you have to get them in the database. You have to put them into that content values structure. All that string manipulation, we don't have any compile time checking, right? We don't know that it's wrong. Like, you know, it might not, if your app won't compile if it's not a string, right? If you forgot a plus or something like that, but we don't know that you missed a comma, right? Until you actually run it. And no type safety too, because everything is converted into a string, and you don't know whether that column is expecting it or not. Okay. At this point, you might wonder, well, we're in an object-oriented language. I didn't see a lot of objects and types other than strings. Okay, so if you had that thought, you're not the only one. There's obviously been people who say there are definitely better ways. It's just not shipped with vanilla API. So here we have something called ORM, which what everybody calls it. Nobody uses the clumsy full name, which is an object relational mapping or mapper. The way to think about it is it's just an object-oriented abstraction over SQL. So, you know, why can't I use those model objects directly with the database? Like, why do I have to convert it by hand into content values? Why do I have to use the cursor methods to turn it back into the model objects? What if records in my database were objects and I could define my tables in my classes? And to support this, you need to be able to have objects that know how to take those model objects and put them into the database, right? There's actually two implementation styles. One where the objects themselves know about how to persist themselves, that's called active record, and the other style, which is the only style that we've talked about in the rest of this talk, which is DAO, which stands for Data Access Objects. We'll get back to that. So on Android, there are many different ORMs. I've only listed 4 here which are still kind of active or been updated in the last year or two. There's a whole bunch that have sort of fallen by the wayside. Does anybody use any of these or is currently using any of these ORMs? A few people. I'm very curious what you're using instead of vanilla or ORM. I'm going to have a look at ORMLite. It's one I'm most familiar with. I've built production apps with it. It's just sort of an example of ORMs in general. Okay, so ORMLite itself was started in 2010 and had its last release in 2016. So I think Gray, the author, has sort of stopped working on it. Now, it's not a specific not a specific Android ORM in that it works just on regular Java outside of Android, and it also works not with just SQLDelight, but with other SQL implementations like Postgres or MySQL, Oracle or something like that. It's heavily based on annotating your model objects and uses this DAO, data access object pattern. So let's have a look at what using ORMLite looks like. So we're going to stick with the same example of the feed entry, which represents an article that you might find in an RSS reader. First thing to see here is that to define the table, we don't have any SQL here at all. This is just a regular Pojo with a lot of annotations on it. There's a lot of boilerplate at the bottom. Got some getters and setters there. At the top here, you see these annotations which tell ORMLite how to create your table data. So we have to name the table something in the database. That's what the first database table annotation is for. And then each of the fields, we also have an annotation to tell it that this is a field which should be persisted. because you might have some sort of temporary or helper fields that don't need to get persisted. And you don't necessarily have to specify the names of the columns, because with reflections and annotation processing, it can actually figure that out. So unless you have some special need to override them, like I have in the third example here, it will just have some sort of strategy. So whether your in-house style is snake case, camel case, mixed, whatever, you can teach it and say, like, as long as your data model is consistent everywhere, you can teach it to do that. And any other constraints you want to define on your columns, you would put as annotation elements there. Okay, so now we have an example of how to define an entity. What about how do we create the table? How do we hook that up to OpenComfort? So already we see a bit of an improvement over the vanilla API. We don't have a string anywhere here. Because all the information about how the table should be represented is encoded in the annotations, we just have to pass it the feedEntry.class to this helper table utils, and it will just figure out the SQL that it generates, or that it should generate. And we want to get data in. So I was mentioning these data access objects, which are the ways that you actually put information and get information out of the database. So again, we don't have to do any sort of string manipulation like we did on the vanilla API. We just pass an instance, or not the class object from our model to this getDown method. We get back a class that has methods like create, update, delete to do our standard database CRUD operations. And after we get the DAO object, we have some sort of our model. I think I called it feedEntry model in the previous section, but here you get the idea. We can call setters on the object to initialize it, and then to put it into the database, we just call dev.create. So here, no string manipulation at all. We work directly with the objects. Great. To do updates, very similar. You have some sort of existing object. You want to change some attribute of it. You mutate it. You call update. The DAO and ORMLite know that the entry had some sort of unique ID, and it would use it to update that row. Similarly for deleting something altogether. On to queries. Queries use this Fluent API provided through something called the Query Builder. And you can see it again, we're not, this is where it kind of breaks down. Starting to see some strings here, right? So the Query Builder has a Fluent API that lets you say, builder.where, the start of your select clause, or your where clause in the select, and and you pass it a string which represents the column name. Because you think, well, how would you do it in Java otherwise, right? If you had to reference that column name in your class, like how would you reference it? So it has to use the string here, and you specify the argument that you want to bind to that. And then you do some boilerplate specific to ORMLite to prepare the query, and then you call the DAO.query method, and you pass in that query. And notice that it doesn't return you a cursor, it returns you a list of your model objects, a collection of those model objects. So it's done all that mapping internally for you. Okay. For more sophisticated queries, you can actually create these objects which know a lot about what the SQLDelight syntax is for queries. You can add likes, you can join different where clauses together, you can add grouping operations. Same idea at the end, you just call prepare and then pass this all into the DAO query method. Last thing I want to mention is that ORMLite, being an object relational mapping, supports relations between entities. So suppose we have the association that every feed entry, every article is written by an author, and the author has attributes like name, email, age, whatever. And we want to model this relationship so that every time we fetch a feed entry from the database, we can also look up details about the author. Maybe we're rendering it in our CMS, and we want to put the byline at the top of the article. So here you model this in ORMLite by saying that an author has a one-to-many relationship with feed entries, because an author could write more than one article, but say, for example, that articles, the feed entry, are only written by one author. So you set up this foreign collection field annotation. You tell ORMLite, because it has special logic to do lazy loading and stuff, so it's not just a regular collection, it's a foreign collection. And then you have the reverse from the feed entry. You say that that author comes, it's not an attribute of my table, it comes from a different table. And then, so when you fetch feed entry, it will fetch the associated author, and you can just access it like you would any other member field in your object. Oh, and the final thing I want to say is that you can also do raw SQL queries because this abstraction breaks down after a while. Like if you have super complicated queries, you're not going to be able to do the raw SQL that you need. So they do have a raw SQL method that you can call into. All right, to summarize, and some of these comments aren't specific. I'm not going to, picking on ORMLite, I actually think it's pretty full-featured ORM despite its light name. But general sort of criticism about ORM and praise about ORM. Because we're working in Java, we get type safety and compile time checking. Those are good things. There's a lot less boilerplate. Not once do we have to convert into content values or directly talk to cursors and pull out the columns. But there's a bit of a learning curve, as with any library, right? So I actually have this sort of the negative thing for the rest of the talk is that it's something you have to learn. But ORMs, because they're implemented in different ways, they each have their quirks. So ORMLite in particular has a big gotcha that if you are iterating a foreign collection, and in a while loop or for loop, you might early exit, but that's dangerous in ORMLite because you leave the database connection open. So you must remember to always close the connection when you're iterating over a foreign collection. Otherwise, you run out of connections or something like that. But that's something that's kind of buried way in the documentation. So you have to learn these quirks about each library. And there's something we'll talk about impedance mismatch. So object-oriented languages, you have pointers, right? Objects can refer to other objects. That's not really how it works in SQLite. Things are relational algebra, other tables. You have SQL strings are a little bit different, right? They're usually fixed length for performance, or they might have special relaxed rules about matching when there's trailing white space or something like that. But that's not the case when you work with strings in Java. So you're always sort of fighting the abstraction if you have to do anything that's kind of non-trivial. And this is hotly debated for ORMs, whether it's actually efficient enough for you to use. Because you're making copies from the database into the Java land, and you're working with a copy of the data. There's a lot of memory allocation. Some people worry about the cost of reflection. But different ORMs try to get around some of these restrictions. Like some of them are completely reflection-free. They use annotation processing at compile time. But it's something to be aware of. Okay, so quick diversion. How many of you have heard of NoSQL or Realm? Yes? I don't have time, unfortunately, to get into these. Maybe this will be for a future talk. But you might be thinking, well, SQL is 30, 40, 50 years old. Why do we have to still use it on modern OS like Android? Well, if it works for you, then by all means. Firebase is probably one of the most well-known NoSQL databases. Everything is represented as a JSON tree, and you can sync with the cloud. Realm is an object database where it specifically helps you work with relationships between objects, and they can point to each other. However, you don't just work with Android developers, right? You work with backend people who might already have their models in SQL. And you probably have colleagues who are DBAs or people who know a lot about querying and join that can't help you when you run into that. And so there is still a place for SQL on Android, but perhaps these APIs that we were looking at were just poorly designed. So one thing I want to put in your head is that how could we make a better API? So one way that several teams of people have come up with recently is instead of generating SQL from Java, what if we flipped it around and made Java from the SQL? So that's what I want to talk about for the rest here. And we'll start with one approach from Square called SQLDelight. In one sentence, SQLDelight generates Java models from your SQL create table statements. It makes SQL front and center as a source of truth in your app. So I mentioned it's really recent. It's from, I think, beginning 2016 is our first public release, and it's still actively being developed right now. The main part of SQLDelight is an IntelliJ plugin that parses a dialect of SQL that operates right as you're editing code. And it generates code for you to use with the vanilla API. So we can't get around vanilla API. That is our only access to the SQLite embedded engine, right? Unless you are building your own Jimmy layer or something like that. But SQLite aims to make it a lot easier and a lot safer for you to work with that API. One of the developers called it, giving SQL superpowers. It has specific design goals, so if you've used any of the Square libraries, if you try to submit a feature request to them, you know they're super opinionated. So the things that they definitely want to put into SQLDelight are support for immutable value classes. So if you use something like AutoValue or Kotlin data classes, you know what I'm talking about. This is a class that can be created but can't be mutated. So if you have value classes like that, it's a lot easier to reason about what your app is doing. It's a lot easier to reason about its deterministic behavior, and improves your testing a lot. They wanted to, another design goal was to give it type safety and to be able to have a compiler tell you at compile time that there's problems, not at runtime. And they wanted to give you full access to all the features that SQLite has, being able to do joins, aggregate functions, triggers, whatever. And they also had some things that they said they would definitely not do. So they didn't want to make this an ORM. So they never refer to this. Square never refers to this library as being an ORM. In fact, they explicitly do not have support for what I showed when we had the author and the feed entry of having one entity reference another directly. And they absolutely do not want you to define your database using Java classes. So Java classes are not used, like POJOs aren't used for their annotations to tell the database how to create itself. Okay, so let's have a look at how you would use SQLDelight. So suppose you've installed the plugin and you've read the documentation. The first thing you need to do is create what looks like SQL, but it's called, the extension they use is .sq. This is 100% syntactic SQL. It is creating a table with 4 columns in it. The first is an ID column, and it has a constraint that it's a primary key, which means this is the unique way to identify rows in this table. And I have 3 string, they're called text in SQL types, 2 3-string columns, 2 of which cannot be null. So this is, a fairly trivial example of what the create table statement looks like. This was being auto-generated for us. I know I switched examples. If you're paying attention, I had this feed entry before, now it's an article. This is exactly the create table statements that we had to write by hand with Vanilla API, and ORMLite was automatically generating for us. So what does it look like? You put this into an article.sq file. The plugin whirs a little bit, and then you get this file coming out of it. It's an interface called article model, and you see that the columns that we define turn into string constants, but we don't have to write this ourselves. And let's focus on things a little bit at a time. So, so the columns are there at the top, all the names and the table name. And then it has sort of echoed this create table statement. Because we still need, remember, this is just helping you to use the Vanilla API in a safer way. We still need this create table statement because we're going to pass it into the open helpers on create, like this. But here, similar to the way that we were using the Vanilla API, where we just had a string constant for it, but it's generated for us in this article model interface. Back to the .sq file, at the very bottom, you see that it has generated getters for our model class. And to actually make a concrete implementation, like you're not working with interfaces, you need something to represent the model and to hold the data. You can use something called AutoValue, which is a library that Google has developed. And it's as easy as just saying that some class implements this interface, and what it's actually implementing is all these getter methods at the bottom. And the AutoValue annotation, when process-buddy annotation processor, generates a class that will hold an ID, a title, whatever else we had in there, author tags, things like that. And then there's some other SQLDelight specific things, which I'll get into in a second, that you create. But this is it. This is your model object, but it was the guts of it were generated by SQLDelight from your .sq file. So you have one SQ file per table in your project. And not only do you put your create table statements in there, but you actually put all your queries for anything you want to do with that table. So I have a very simple table here called, or a query called select by ID. This is where it slightly deviates from SQL syntax. You have this named, you have this identifier that so you can reference that query later. So this probably all written similar select statements or queries like this. We're just going to get all the columns from the article given a specific ID. So what does this generate? So back in the article model interface, it has generated again a string for us to call the vanilla API with the placeholders. And it's generated this mapper class whose implementation does all that boilerplate for us, where we call on the cursor and it knows that the first column is with that ID, which is a long. The next three columns are our strings. I'm not showing the detail here, but this article model factory create is equivalent to a constructor to create an instance of that article model type. Once we have all these pieces, once we have our model, we have the interface to use to implement something in your database layer, your persistence layer, you might have a method called in Java called getById, and you pass in an ID argument. We use the raw query capability of the vanilla API. We pass in article select by ID, which is the string of the query. And we pass in the selection arguments array, which is all the positional arguments that were represented by the question marks in that query. And you execute that, you get back a cursor. Now remember, we're trying to avoid boilerplate here, so we don't want to have to do all that mapping from the cursor back to our model object, but SQLDelight generates a mapper class for us, which we saw, to take that cursor and get back an instance of your article model. To do insertions, it's very similar. You go the other way now. Your database API might have a save article method. You pass in your model object. You're going to put it into the database, but remember this insert in the vanilla API took content values at the end. Again, SQLDelight has generated in our giant article model class the classes and methods that we're going to need to call to turn our model object into content values so that we can use this vanilla API. So we didn't have to write all that and maintain it. Now, think about what this plugin is doing. Right? It's actually parsing SQL. It knows about SQL. And can generate Java. But because it does it parses SQL and knows what is valid and what's not valid, it lets us do cool things. Like when you're editing it inside Android Studio or IntelliJ, it can tell you that your column has a typo in it because it knows, it has parsed that create table statement. It knows exactly that that isn't a valid column. It knows that this syntax in the where, in its grammar, that it's expecting a column name here. It knows that upper is a function you can call and it expects a column name. So it can tell you this. So you can now you can feel a lot more confident writing your SQL. Even if you don't have your favorite SQL buddy and she's working on some other backend code, you can start writing this and it will be you'll be confident that if there's a syntax error here, it's not right, and when there's no syntax error, it's at least tactically correct. And then other cool things you can do autocomplete too. Again, because it knows all the column names that are valid. When you're writing these complicated queries and it expects a column there, you can hit your options, control space. It's in my muscle memory. But anyway, this will pop up. And other refactorings that you might be used to, like rename, would work too. It would rename the column, and then the plugin would automatically update all of those generated mapper classes, all that things. There's other good stuff I don't have time to get into, but which I'll run through really quickly here. Has support for projection, so when you're returning just a subset of your columns, not the full model object, it auto-generates this custom model that just encapsulates those pieces or those columns that you want and gives you the mapper for it. If you have inserts and updates and deletes that you're reusing all the time, what you're supposed to do is to compile them once and then just bind the arguments. So it has support to help you to do that. Suppose you're a big fan of Joda time, right? And you want to work with Joda time datetime instances in your app and not with Java util time. But SQL only offers you like big int or something. You have to map between those two, converge. So custom Java type adapters allow you to do that mapping. You teach it basically that this column is going to be represented in Java land by Joda time. And here's, when you get an instance of this, I'll tell you how to convert it back and forth. And views, which I've actually not used before, but I put it in case one of you have used views, but they're predefined SQL queries that you can store in the database. So we achieved, or the SQLDelight has achieved the goal of type safety and compile type checking because we're working in Java. We're working with Java models. If you get full access to the SQL, you're allowed to write any SQL you want in that .sq file, and it will help you generate all the code you need to use the vanilla API. There's very minimal boilerplate. We didn't have to do the mapping between cursor and the model objects. Again, there's a learning curve, right? Takes some time to wrap your head around the idea that your SQL is the source of truth. A lot of Java and Android developers probably shy away from having to write it. You probably chose an RM because you didn't want to work with SQL at all. Migration support, so when your database schema changes from one app version of the app to another, that's on the roadmap. I think I've seen issues where they're discussing how to support this, but at the moment, I don't think there's anything going on yet. And for the leads in the audience, or perhaps if you're in charge of deciding on tech, you need to decide whether, at this point in SQLDelight's life, whether you should jump in. Because it is changing, and occasionally the API, an internal API changes, which affects you. Perhaps you really need migration support, and it's not there yet, whether to jump on board. Okay, that's SQLDelight. Now, I don't think this section was as long as the previous one, because it really is a lot easier to use, these libraries. And the Room section was even shorter, so I apologize if you thought I was going to do a deep dive into Room. I actually haven't used it for that long, so I don't have anything insightful to say, aside from to show you some examples of how to use it. So Google at I/O 2017 this summer broke a long-standing sort of silence about weighing in on how you should architect your app. Right? Before they said, we don't really care how you do it, just be good app citizens, a lot of battery, all that stuff. Whether you use fragments or not, it's up to you. But I think the community really wanted them to weigh in and say, well, there are lots of ways to do it, but can you tell us, your ways so that we can at least learn from that? And a more experienced developer can say, well, yeah, they're full of crap, I'm not going to follow them. But I think for other developers who want just sort of an example that comes from Google, it was lacking. So anyway, architecture components, we had a talk about that last month, has a piece called Room, which is a new persistence library. And Google's aim for this Room library is to provide an abstraction layer over SQLDelight to give you fluent database access, so using Java and object-oriented programming, while giving you the full power of SQLDelight. So very similar to some of the goals of SQLDelight. It's even newer, so it was only announced middle of this year, and hasn't quite reached 1.0. They're on the first release candidate this week, so they're imminently about to go 1.0. One person has compared it to retrofit for database queries. So if you ever built some sort of API service with retrofit, you'll feel quite at home using Room. Like ORMLite, it's based on annotations and uses the DAO pattern. So let's quickly look at how you create entities. So this is very similar, again, to ORMLite. You have a Java class that represents your entity, your table. You tell it with annotation elements how to name the tables and columns. And you have constraints that you would specify in the elements to the column info. The second component is the DAO. And this is, if you've used retrofit before, this will look very familiar. You define the methods that you want in your database layer when dealing with this article model in an interface, and then you annotate it with DAO. And then for every method that is doing something into a CRUD operation on the database, like a query or to insert or delete, you annotate it with either a query or one of the other verbs, insert or delete. And the argument to the query is an SQL string. Right away, you'll notice that that string doesn't have any question marks because the annotation processor actually will, those colon prefix arguments map directly to the arguments in your Java method. So it can bind those automatically for you. So that's kind of handy. When Room processes this file, it will generate a concrete implementation of these methods so that you'll get a class that has a look by ID method with an ID argument, and you get back an article. The way that these things are tied together is through the database class, which we'll look at in a couple slides, but let's I'm warning you, this is a big slide. But this is what the automatically generated code looks like, which you're not actually meant to look at, I think. You're just meant to use it. It's long, but again, look at this. This is using the vanilla API, but with a bunch of other room-specific things on it. But most importantly, you didn't have to write this or have to maintain this, right? You just had to annotate your Java class and your DAO methods and it generated this. So if we highlight a couple sections of it, here's that string of SQL, which we've seen all of these libraries need to create, because ultimately at some point they need to call the database query method with the SQL. And in the fourth or fifth line there, it is binding our argument that we're passing in, the ID argument, to the statement, and then calling query to get back a cursor. And of course, by now you're familiar, the cursor needs to be walked through to get all the columns and the data out, and then we assign them into our model object, and then we return it back to the user. So I was mentioning that this class called database is what ties everything together. You put an annotation on an abstract class for your app. We'll call it app database. You have to tell Room all the entities that make up your database. So you list all the tables up in that entities array there. And then you define a method, an abstract method that returns a DAO, however you want to get access to the DAO later. So if you remember ORMLite, the way you do it is you have the DAO helper and you passed in like article.class. Here you just say, I want to access the DAO by calling article model. And then you get back an article DAO, which implemented these methods, and you'll be able to call it. So the way it looks like in practice, once everything is all hooked up, you ask Room for an instance of your app database, pass the .class. And then from that DB reference, you just call whichever DAO. So imagine, in our app database, we had multiple DAOs because we have multiple tables. You call whichever method to get the DAO. In our case, it's article model, and then you call a method on it, load by ID. Pass in your ID, and you get back the article model object. Similarly, if you're inserting, this is what it would look like. So there's not enough time to go through all the other cool stuff that Room has, but you can obviously watch any of the videos. Some highlights that stood out to me is that by default, they prevent you from executing queries on the UI thread, and that's a hard stop or crash, I think, because that's a common problem when you're hooking up like a recycler view to a database to accidentally, or not even intentionally, accidentally executing some sort of a query that slows down your UI. Similar to the way that retrofit works, if you just change the return type of those DAO methods, instead of just being like article, you wrap it with live data or observable, you suddenly get an implementation that supports reactive programming. So that's great out of the box. And they also have strong support for migration and testing those migrations. So it's like first-class helpers and classes to help you to do migration. And the last thing, which is really cool, is you can, I think in one line, switch your database to be completely in memory, so not hitting disk at all. And that's useful for testing, obviously, because you can reset the database very easily to restore to a known state. So, Room. You get all the benefits that we're looking for, and some other things. It works with our architecture components, so if you've already got the Kool-Aid and you're starting to switch your app over, now you have a persistence library you can use with it too. I put down learning curve again. It's so new that there's only been a handful of articles and videos teaching you how to use it. Same idea that it hasn't quite reached the 1.0 release yet. So whether you jump on board now or not, you'll have to evaluate yourself. Just a few final things. As you can see, like with two big implementations that put SQL front and center, it's not going away. Even though there's Realm and even though there's Firebase, and Cloud Store, all these things, SQL is still around. Fortunately, there's a lot of people who know how to write SQL, but getting used to it, I think, is something to be comfortable with. Working with any of these libraries, like picking, I call it the developer's dilemma. There's so many ways to do I don't know, a view indicator, or so many ways to do custom view widgets or rounded corner libraries or something like that. Which one do you pick? The first step for me is just being aware of all these implementations out there, finding out what their pros and cons are. It's just part of the good practice of knowing how to evaluate technology choices. And the last thing, what I mean by lock-in inertia, is that if you already have developed extensively an app in one kind of ORM, it's not that easy to switch. You think, oh, well, I've made my app modular. I have this database layer that I can kind of dependency inject. But it's like, completely different paradigm if you switch from, say, like SQL to NoSQL or the other way around. So I don't know what to say about that, aside from, definitely build it in a modular way so you can replace as little as possible and to be able to have good tests so you know when things break. And with that, I think that is the end of the talk. So if you have questions, I'd be happy to take a few before we take a break.
What do you find the advantages with Realm? Because we use that in work, it just seems so much more easy, so much easier than a lot of this.
So I've only used, the question was what are the advantages of Realm? Of Realm?
Yeah.
I've only used it for just to play around with it. One of the biggest complaints that people have for a long time is that all your model objects need to extend from Realm object. But I know in the most recent release, you don't have to do that. You can implement this interface. So for anybody hesitating about that because of having to subclass, that's no longer a requirement. Another criticism, I used it and was able to get something set up really quickly, which was great. The querying, if your querying needs are complicated, I don't think Realm's query language is as sophisticated as SQL. But again, for your use case, if that works, great. I think Realm being controlled by a single company might be a concern if you're afraid of lock-in. But yeah, I don't know. I haven't used it enough to say I have an experience with it. I don't know if anybody else has experience with it.
Realm's pretty big too. As a dependency, it's sizable.
Sorry, I couldn't be more helpful.
Yeah, no problem. But that's exactly like you said. It's very, very easy to get started. 3 lines of code.
Amazing documentation.
Yeah.
It's really well done. Okay, we'll take 10 minutes before Josh talks about React Native.